going to discuss about our project titled Reduction of Voltage Stress in 3-phase to single-phase cycloconverter using space vector pulse width modulation. Our college name is Vailtech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. Normally, cycloconverter are used to generate variable frequency and variable voltage. Normally, in cycloconverter, switches are used. They are thyristors or transistor, but nowadays thyristors are not used because it has low switching frequency when compared to transistor. In transistor we have BJT, MOSFET and IGBT. In existing system they are using BJT. Now we are going for MOSFET and IGBT because the switching frequency of MOSFET is very high when compared to BJT and IGBT, and IGBT the on-state losses is less when compared to MOSFET. Normally the switches are used by giving the gate pulses using driving circuit, but due to the voltage stress across the switches will be automatically turned on without giving the gate pulses. This will create short circuit in the converter. The voltage stress will occur across the switches only. It will occur because in switches normally it consists of 3 junctions, J1, J2 and J3. Junction, as soon as we given the supply, the junction J1 and J3 will be forward biased and junction J2 will be reverse biased. The capacitance will be formed in junction J2 because of the smallest distance. As we know the formula, C is equal to epsilon A by D. The distance is very less in junction J2. Due to this, the capacitance will be more in the junction J2. This will occur the fault switching.
Generally, in a 3-phase to single-phase cycloconverter, 6 switches will be used to produce the single-phase output, and this is the prototype of a single-phase to single-phase cycloconverter. Here 4 switches are used, and the MOSFET is used as the switches in the cycloconverter. And generally, in a cycloconverter, the switches will be divided into 2 groups as Group A and Group B. And similarly, in this circuit also, the 2 switches will come under Group A and 2 switches will come under Group B. So, as you can see, at a particular instant, switch 1 and 2 must be turned on, and at the other instance switches 3 and 4 must be turned on. So depending upon the switching pattern, the switches should get turned on. So because of this voltage stress that is formed across these switches, it may lead to the fault switching. That means this 1 and 3 switch will get turned on at a particular instant. If 2 switches from a same group, that is from group A, gets turned on, means it will lead to the short circuit. When it gets short circuit at this path, the output voltage will not be reached to the load, and hence the output voltage will get distorted. So we are going to reduce this fault switching by using a PWM technique. Generally, this pulse width modulation technique are used to control the gate pulses that is given to the switches. This PWM technique will be stored in a microcontroller, and by using the microcontroller, the gate pulses will be given to the switches. In order to control a 3-phase voltage, the sinusoidal PWM technique or a space vector PWM technique will be used. The space vector PWM technique seems to be the most efficient one, as it gives the gate pulses to these switches only at a certain period of time, that means only at a certain instant. That's why the voltage transient formed across these switches will be less. As these voltage transient, that means the variation of the voltage transient is less, and hence the capacitance that is formed inside these switches will get reduced, and hence the stored charge inside the capacitance will not be enough for providing the gate pulses to the switches. Hence we can reduce the fault switching by using a proper PWM technique.
This is the normal single phase to single phase cycloconverter kit. This transformer is used to convert the incoming 3-phase supply to the single phase and is given to the MOSFET switch. This is the another transformer which is given to the power supply circuit. This power supply board reduces the voltage to 5 volt and it is given to microcontroller for controlling the driving circuit of the MOSFET. This is the 4 driving circuit which controls the MOSFET, and the output is obtained. This microcontroller controls the driving circuit of the MOSFET. This is the frequency controller board which increases or decreases the frequency. This is used to increase the frequency, and this switch is used to decrease the frequency, and thus the single phase to single phase output is obtained. Here we can connect loads such as motor and bulb. and we can use for various applications such as in induction motor and for ship propulsions and in coal mines. Thank you.